Hi, today we're going to discuss the law of sines and the law of cosines. These are your two main tools you have at your disposal for figuring out side lengths and angles for non-right triangles. Let's start with the law of sines. What is the law of sines? For a triangle like this, with side lengths capital A, capital B, capital C, and angles lowercase a opposite the capital A, lowercase b opposite the capital B, lowercase c opposite the capital C, we have these ratios. Side length A over the sine of A equals side length B over the sine of B equals side length C over the sine of C. And the reciprocals are true too. Sine of angle A over side length A equals sine of angle B over side length B equals sine of angle C over side length C. That's it. So that's all wonderful, and yeah, you should memorize this, but what does it mean? Well, realistically, you wouldn't use all three like this. You would use two. Let's use a real life example to show how this works. Let's say we had a triangle look something like this, where we have no right angles anywhere. We have 118 degrees, 32 degrees, and 30 degrees. We have this long side length here is 46 meters, and we want to know what this side length is right here. Well, we can use the law of sines for this, because side length x over the sine of the angle opposite x, which is that guy, 32 degrees, is equal to side length 46 over the angle opposite 46, which is 118. Okay, multiply both sides by the sine of 32, and you end up with, let me put the little arrow here, x equal to 46 sine of 32 over sine of 118. That's it. So that's the law of sines in action. The big thing to know about the law of sines is you have to have two things that are opposite from each other. You have to know this angle and this side, or this angle and this side, or this angle and this side, and then one other piece of information. If you don't have things that are opposite of each other to start with, you can't use the law of sines. You have to use the law of cosines. We'll talk about that later. But the law of sines is easier than the law of cosines. There's less going on. It's just the ratio of these guys will equal the ratio of these guys equals the ratio of those guys. That's it. That's all there is. So let's solve one more, then I'll have you solve a few. Here's another example. We have 118 degrees here, 52 meters here, 18 meters here, but we don't know either of these two other angles, and we want to know what that angle is. How do we use the law of sines? Well, use this version. Sine of 118 over 52 equals the sine of x over 18. 118 is opposite 52, so sine of 118 opposite 52. Sine of x opposite 18, sine of x opposite 18. They're the opposites, okay? And these ratios are always going to be the same for all the sides and angles in the triangle. So, with this, we can multiply both sides by 18, and we end up with sine of x equals to 18 times sine of 118 over 52. And then we can take the sine inverse of both sides to get x equals to the sine inverse of 18 sine 118 over 52. So you'd plug all that into your calculator and figure out what the answer is, and that answer is whatever that number is right here. The thing is, many times on the ACT, for the few questions I've seen that use the law of sines, they don't actually have you solve for the angle or the side. They just want you to set up the formula. So let's do that right now. Let's have you do a few of those. Can you solve for x in this one? It says 62 degrees, 58 degrees. This is 19, this is 21. What's x? Just set up a formula. Pause the video, resume when you're ready. All right, little red herring here. I threw in the 21, you don't even need the 21. So let's see, the ratio here will be equal to ratio here. Let's see, so we want to know side length, so I put the side lengths on top. X over sine of 58 is equal to 19 over sine of 62. Multiply both sides by sine of 58, and you have x equals to 19 times sine of 58 over sine of 62. Then you can plug all that stuff in your calculator if you want and get the answer, but usually they just want you to set it up, or they'll give you a whole, A is this, B is this, C is this. They'll give you a bunch of signs of 62, 58 on top and bottom, and maybe whatever the other angle is here, what would that be, 60? They give you one of 60 in there, and they would just give you a bunch of different variations and say, pick the one that actually represents x. So if you can do this, if you can set it up correctly, you can get the answer. How about this guy? 20 meters on this side, 10 meters on this side, 40 degrees, x degrees. What's x? Pause the video, resume when you're ready. All right, since we want to know the angle, I'd use the version where the sines are on top. So I'll have sine of x over 20 equals sine of 40 over 10. So multiply both sides by 20, and I have sine of x equals 20 sine of 40 over 10. Then take the sine inverse of both sides, and you have x equals to the sine inverse of 20 sine of 40 over 10. And then you get whatever that is by plugging it into your calculator, but usually they would just give you something like this and give you different options. They say, is x equal to sine inverse of this? Is x equal to sine inverse of 10 times sine of 40 over 20? Is it, 10 over 20 sine of 40? They give you all kinds of different options. Pick which one is right. And if you don't actually solve it, you may be kind of hard to figure that out. You just be guessing, but just set up the formula. And you pretty much, you start solving and you realize probably at this step, oh, that's what x is going to be. So there you go. Let's do a couple more. Okay, how about this one? Let's solve for x, where we have 35 degrees, 45 degrees, and 10 meters. Pause the video, see if you can set up a formula for x. All right, ready? Well, we need an opposite formula here. We have an opposite here, but we don't have an opposite here. But we can get an opposite there, can't we? Because the sum of angles inside a triangle sum to 180 degrees, no matter what the triangle is. It doesn't have to be a right triangle. Any triangle works that way. So 45 plus 35 is 80, so this is going to be 100 degrees right here. So we have x over sine of 100 equals 10 over the opposite one over here, sine of 35, which means x equals, multiply both sides by sine of 100, 10 sine of 100 over sine of 35. And that equals whatever that is, but they're almost always going to ask you just out of a lineup, well, which formula represents x? They'll give you a 10 sine of 100 over 35. They'll give you 10 sine of 35 over sine of 100. They'll give you sine of 100 over 10 times sine of 35. They'll give you all this kind of stuff. And then you just have to, pick out a lineup. And if you set it up and do this, you should be able to do that. And if they ask you to solve it, which is very unlikely, it'd be whatever number that is. How about this one here? You have an isosceles triangle. These two sides are the same, x and x. These two angles are the same. This is 10 meters and that's 40. What's x? Pause the video, resume when you're ready. All right, well, they don't explicitly give you these, but you know these two are the same. Angles of the triangle have to sum to be 180, so these two sum to be 140, 180 minus 40. So that's going to be, 140, 70 degrees each? These are each 70 degrees. So, law of sines, x over sine of 70 equals 10 over sine of 40, meaning multiply both sides by sine of 70. X equals 10 times sine of 70 over sine of 40. And you can plug that into your calculator, but again, they would most likely just ask you to pick this out of a lineup. So there you go. Let's move on to law of cosines. Okay, same setup as before. For law of cosines, we have capital A, B, and C, lowercase a opposite the A, B, lowercase b opposite the big B, lowercase c opposite the big C. You start out just like the Pythagorean theorem. C squared equals A squared plus B squared. But this isn't a right triangle, so that's not sufficient. You also then have to subtract 2 times capital A, capital B, cosine of little c. Does this work when in a right triangle? Well, what's the cosine of 90 degrees? Goose egg, 0, which is why this works. This just becomes the Pythagorean theorem for a right triangle. But for a non-right triangle, you have to subtract this bit over here. So just remember that. It's just going to be minus 2ab cosine of c. If you can remember that, you got the law of cosines. So when would you use this versus the law of sines? Well, mainly when you don't have those two opposites. If you don't have an angle and the side opposite to that angle, any of these three, you can't use the law of sines. You have to have that to use the law of sines, right? Well, law of cosines works when you don't have that. Mainly these two cases. When you have only the sides, all three sides, but none of the angles, or when you have side, angle, side. The side, angle, side is the one that comes up most often. So be used to pointing out, seeing the side, angle, side, and knowing, that's a law of cosines problem. So they love the side, angle, side on the practice test I've seen. So here we go. Let's solve one. This is a classic example where you have the side, the angle in between, and then another side, and you're trying to solve for the opposite side length. Well, that is the direct application of the law of cosines. In this case, you would have x squared equals 12 squared plus 14 squared minus 2 times 12 times 14 times the cosine of 62. If you want to know what x is, take the square root of both sides. That's it. And they would almost always never have you actually solve this. They would just say, they'd have you pick this out of a lineup. A lot of times mixed in with a couple of law of sines type answers, and then this and maybe one other for law of cosines. So it really is about figuring out, oh wait, this is a law of cosines answer. It's a law of cosines type problem. Yeah, I'm going to pick a law of cosines answer. So it's about figuring that out. It's about figuring out, which answer looks right. Maybe they give some other angle in the problem somewhere else. They'll throw in that angle over here, but just be able to set it up. If you can set it up, then you can get to this point and then you're good to go. Let's do one more. Here's an example where you have a triangle with side lengths 10, 11, and 12, and the angle opposite the 12 is what we're looking for. How in the world would you find that angle? You want to give it a shot on your own, pause the video, otherwise I'll just do it. Ready? We'll set up the law of cosines using this as your c since it's opposite the cosine. So in this case, you'd have 12 squared equals 10 squared plus 11 squared minus 2 times 10 times 11 times the cosine of x. Right? So now you just want to isolate x. So you'd subtract all these two things. You have 12 squared minus 10 squared minus 11 squared, subtracting from both sides of the equation, that is, equals minus 2 times 10 times 11 over cosine of x, or times cosine of x rather. So now divide both sides by negative 2, 10 times 11, minus 2 times 10 times 11, and you're left with just the cosine of x. What do you do then? Take the cosine inverse of both sides. So really, you would then just take the cosine inverse of this whole thing. You do that over here as well, cosine inverse, and you just have that equal to x, so forth. So this guy would be your answer. If you're looking for an angle, you're always going to have a cosine inverse. If it's a law of cosines type problem, you're going to have a cosine inverse and something that looks like the c squared minus a squared minus b squared and the 2ab down below in the denominator. But that's it. These are the two types of law of cosines. Either you have side, angle, side, side, angle, side, side, angle, side, something like that, or you have all three sides and you're looking for an angle. Let's have you do some. All right, let's suppose you have this situation. Side length 10, side length over here 12, angle in the middle 35. What is side length z? Give it a shot. Pause the video, resume when you're ready. All right. Z squared will be equal to 10 squared plus 12 squared minus 2. That's a 2 rather, squared. 2 times 10 times 12. That's the c squared equals a squared plus b squared minus 2ab cosine of whatever's across from z, 35 degrees. And if you want to know what z is, you take the square root of both sides. Done. Finding the length of the side opposite using the law of cosines is just about setting this up. A squared plus b squared minus 2ab cosine of c, whatever angle c is. In this case, it's just the angle opposite the The side angle side. There you go. All right, let's try one more. You do this one. Here's a triangle with side lengths 5, 6, and 8. You have angle Y up here. What's the formula for angle Y? Pause the video, resume when you're ready. All right, we set up the law of cosines formula. We want to see this angle, so this is going to be our C over here. 8 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of Y. Then start putting everything on the other side. You have 8 squared minus 5 squared minus 6 squared equals minus 2, 5 times 6 times the cosine of Y. Divide both sides by minus 2 times 5 times 6 minus 2 times 5 times 6. So those cancel. And then if you want to know what y is, take the cosine inverse of this guy. So it'd be cosine inverse of 8 squared minus 5 squared minus 6 squared over minus 2 times 5 times 6. And that would be your y, which is approximately that number. All right, let's mix things up a little bit. I'm going to give you some triangle examples, and you tell me, is it law of sines or is it law of cosines, and how would you set up the formula? Length 7, length 8, length x. We have 50 degrees here, 60 degrees here. What's the side length x there? How do you solve for x? Would you use the law of sines or law of cosines? It's the law of sines. You have opposites here. You have this angle, you have this side, and you have other stuff. You can definitely use the law of sines. So how would you set it up? Give it a shot. Resume when you're ready. All right. Well, we're looking for x. I would start with x on top. X over the sine of the angle opposite of it is 60. And that's going to be equal to angle 8. 8 over sine of 50. And then we just multiply both sides by sine of 60. And you have x equals to 8 times the sine of 60 over the sine of 50. And again, they'd have you pick out x from a lineup most likely. 8 times sine of 60 over 50. 8 times sine of 50 over sine of 60. 8 times cosine. They'd have like a couple of law of cosines type problems in there with, you know, this side squared plus minus this side squared, or who knows. I don't know. They do all kinds of crazy stuff. But you just look at it right away and go, law of sines question. Yeah, here it is. So here's what it is, and done. It's not that complicated. Let's try another one. All right, you have this problem here. Side length 8, side length 9, side length z, angle 65 degrees. Is this a law of sines question or a law of cosines question? It's law of cosines. You have no opposites. You don't have the angle opposite the 9, you don't have the angle opposite the 8, and you don't have the side opposite 65. So this is a law of cosines question. So let's set it up. How would you solve for z? Treat z as your c in the a, b, and c world. So this would be z squared equals 8 squared plus 9 squared minus 2 times 8 times 9 cosine of whatever's opposite z, which is 65 degrees. And that's it. You want to solve for z, take the square root of both sides. And it's going to be that, whatever that is. Let's try one more. All right, we have this situation here. Side lengths 21, 30, and 35, and we want to find angle x. Is this a law of sines or a law of cosines problem? Law of cosines. How would you go about setting it up? Pause the video, give it a shot, resume when you're ready. All right, this is the one opposite our x, so we'll have that be our c. So we're going to have 30 squared is equal to 21 squared plus 35 squared minus 2 times 21 times 35 times the cosine of x. Shift all this stuff over there. 30 squared minus 21 squared minus 35 squared. Whoops. Let me write that down correctly. Minus 35 squared equals the negative of that. We can also just divide by that, both sides. Minus 2 times 21 times 35. And that's going to be equal to cosine of x. And then you take the cosine inverse of both sides. So you end up doing the cosine inverse of this. Cosine inverse cancels out the cosine. X is equal to the cosine inverse of 30 squared minus 21 squared minus 35 squared divided by minus 2 times 21 times 35. And you get whatever that is, but you would not actually ever solve for this. You would just be able to pick this out of a lineup. One thing to note for both law of sines and law of cosines, but mainly law of cosines, is they don't always give you the side angle side beautifully. A lot of times they'll have you figure out the angle first and then determine, oh, that's a law of cosines problem. Something like this. I'm going to put it over here on the screen. This is one of the problems from a practice exam, and I've seen a couple of other problems similar to this. They give you something like this. I don't know if you can read this or not, but it's the same diagram. I just drew it for myself. 20 degrees here, 60 feet here, 25 feet from here to here, and they want this side right here, x. Law of cosines, it could be because you have side, angle, side, if you can get that angle. Can you get that angle? Yeah, because this is supplementary to this angle right here, and you can get that angle because this triangle has 20, 90, so this means this would be 70 degrees, which means this one is 110 degrees. Now you have side, angle, side. I mean, you could just look at the answers at that point and say, well, which ones are law of cosines type answers? Well, it's going to be the last two. Which one has an angle of 110 degrees in there? There's only one of them. Done. So it's more about recognizing what type of problem it is. Is it law of sines, law of cosines? Last little piece of advice, a bit of information for the ACT. In the practice exams I've seen, a law of sines or law of cosines problem usually shows up. It's usually a law of those, it's usually a law of cosines problem over a law of sines problem. Not always. Just know for law of sines, you have to have the side and the angle opposite that side, and then one other piece of information. Otherwise, you can't use law of sines. For law of cosines, it's always side, angle, side, or it's all three sides. Then you're solving for an angle. That's all I got for this time. Hope this helps.